Solving systems of equations, part 3 here. So we are going to move to some application problems, which we had done with a calculator before, but you also need to be able to work them out algebraically. So let's get started. We have someone, Melendez, she needs to purchase a new radiator for her car and have it installed by a mechanic. There's two garages, Steve's Repair and Greg's Repair. At Steve's Repair, the parts cost $200 and the labor cost is $50 per hour. So I'm going to write an equation for Steve's Repair. So Steve's Repair, the equation is, and I'll use cost C is equal to the $200, 200 plus $50 per hour, and I'll say 50H, where H is the number of hours. Okay, so H is number of hours. And at Greg's, what do we have? Okay, so Greg's garage, the cost is $375 for parts plus $25 per hour for labor, how much time it takes them to install the radiator. How many hours would the repair need to take for the total costs at each garage to be the same? So the question is, when does cost equal cost? In other words, the cost of Steve equal the cost of Greg. When are the costs the same? Well, they want to know when this C is equal to this C. Well, that's the same as since the C are equal to these, all I have to do is set this equal to this and solve for the number of hours. In other words, 200 plus 50H. When is $200 for parts plus $50 per hour equal to $375 per parts for parts plus $25 per hour? In other words, how many hours? How long will it take? Or how many hours need to be worked when the cost is the same? So now it's just a matter of solving a fairly simple equation, minus 25H. Okay, and so now I have, let's see, 200 plus 25H is equal to 375. And now I'm going to subtract 200 from both sides, minus 200. And I have 25H equals 175. And so I'll say, okay, I'll rewrite that real quick. 25H equals 175. So I'll divide both sides by 25, okay? And then H will be equal to 7. So how many hours would the repair need to take for the total cost of each garage to be the same? And the answer is 7 hours. Okay, 7 hours. So she can use that to decide which garage she's going to use. Okay. Last example that we'll do, Pat Williams is a pharmacist and he needs 500 milliliters of a 10% phenobarbital solution. I have no idea if that's right, the pronunciation. She only has a 5% phenobarbital solution and a 25% phenobarbital solution available. How many milliliters of each solution should she mix to obtain the desired solution? This is confusing, all of this stuff. So what we're going to do is set up a system of equations. Okay, we need, what do we need? How many meters of each solution? So we're going to say that X, we have to do this, equals milliliters of 5% solution, right? Because 5% phenobarbital and 25%, and we need a 10%. So X is going to be the amount of milliliters of 5% solution. Okay, then Y will let equal the amount of milliliters or the number of milliliters of 25% solution. Okay, so we're going to mix these together, right? The 5% solution and the 25% solution to get 500 milliliters. So that implies that our first equation should be X plus y has to equal 500. Okay, so we have one equation. That was fairly simple. Let's make sure we understand what's happening here. We're taking this solution plus this solution, we're mixing them together, and we need a total of 500 milliliters. Okay, what else do we know? Well, let's see. What we need now is 5%. There's going to be this solution has 5% of phenobarbital, and this solution has 25%. 25% of it is phenobarbital. So what we can say is that we're going to take the 5% of the number of milliliters, multiplication, plus the 25%, notice I'm changing this to a decimal, times the amount in the of the 25% solution, and we need it to be a 10% solution, so that's 0.10 of the 500 milliliters. Okay, so 5% of this is the pheno. 25% of the Y solution is the pheno. I gave up on barbital. Yes, I'm sorry. And we need it to end up to be of the 500 milliliters. Only 10% can be the pheno stuff. Okay, so let's clean this up a little bit. So we have 0.05x plus 0.25y. Oops, I forgot the 5. And that is equal to, let's see, 0.10 times 500 is equal to 50. Okay? And so now I have another equation. I have this equation and I have this equation. So I'm going to move this equation down here below. X plus y has to equal 500. Okay? And so what do I need to do to solve this with elimination? Well, I'm sorry, with the addition method. Okay, well, I guess I can make each of these, what can I do here? I could make this 5x here if I multiplied it by 100. So I'm going to multiply this by 100 right here. Okay? And then if I'm going to add, I need them to drop out. So 100 times 0.05 is going to be 5. That'll move the decimal 2 places to the right, so 5x. So if I multiply this one by -5, I would get a -5x, and my x's could drop out. So this equation becomes 5x plus 25y, and 100 times 50 is equal to 5,000. Very good. Okay. And then let's see, -5x minus 5y equals -2,500. Very good. So now I can combine these two equations and the x's drop out. And 25y minus 5y is equal to 20y. And then 20y is equal to, let's see, 5,000 minus 2,500 is 2,500. Yes. Solving for y, I get y equals 125. And that's dividing both sides by 20. Sorry. 125. Okay. So y equals 125. And then I know from here that x plus y must equal 500. Well, since I know that y equals 125, I can just substitute that and get x plus 125 equals 500. Subtracting 125 from both sides, I get x equals 375. And so I have my solution. Yes, I need 375 milliliters of the 5% solution. And I need 125 milliliters of the 10% solution. And this makes sense, I'm sorry, of the 25% solution. Sorry, 25% solution. That was what y represented. And this makes sense. There's a lot more of the 5% solution to combine with the 25% solution because we're trying to get to 10%. So there should be a lot more of the lesser solution. Okay, that is it, and I am out.